Alright, so in this video we're going to go over probability, some basic probability definitions, and rules, and things like that. So two types of probability we're going to talk about is experimental and theoretical. Experimental means the result already happened. So let's say, for example, I said, hey, I flipped a coin 60 times and landed on heads 40. That's experimental because the experiments already happened. But if I said, what is the probability of landing on heads without any results, it's theoretical because it's what is about to happen. So experimental has already happened in the past. Theoretical, we're predicting what's happened in the future. So that's the difference. So what this slide means is that all of our answers in decimal form, because we can have decimals and percents. And the way you go from decimal to a percent is times 100. Is all your answers need to be between 0 and 1. You cannot have a number negative and you cannot have a number greater than 1. Like, for example, the probability of flipping a heads is 0.5, which is 50%. You cannot have a probability of 1.5. That's 150%. That makes no sense. So that's why this is important. That means probability of event X. You hopefully have seen probability before, but probability is simply just events over number of outcomes. So it's how many events are we looking for over a number of outcomes. Alright, so let's go through some examples. So first off, there's rolling a single die. There's only 6 sides to a die. 1, 2, 3, 4, 5, and 6. And the probability of rolling a multiple of 4. Well, there's only one multiple of 4. It's 4. So we do not put 4, we put 1, because there's one number we are looking for. So 1 divided by 6, you can take that in your calculator. 1 divided by 6 is going to be 0.167. That's the decimal. That's the one that we're talking about between 0 and 1. And then you can put it as a decimal by just moving the decimal 2 times to the right. And that's the percent. Find the probability of rolling an odd number. We got 1, 3, 5 are odd numbers. So 3 over 6. We're just on the 1, 0.5, and that's 50%. Even, it's just the opposite. 2, 4, 6. There's 3 over 6. And 0.5 and 50%. It's okay, the answer is the same. It's no big deal. Alright. So we're going to go through this. So I know if you're listening, you might not know exactly what a deck of cards is. So if you want to bring up in Google Images a deck of cards, I'm going to go through this pretty quick. I know how many of each one of these there are. I've worked with deck of cards many, many times. So if you don't know, pause the video, get a picture of all the cards, and you'll understand where I'm coming from. So first off, all these tell you that there's 52 cards in the deck. I'm not going to sit here and explain how many cards and all that whatnot in the deck. Let's find the probability of drawing a jack. Well, there's 4 jacks in the deck. So 52 cards. So 4 divided by 52, say 0.08. So an 8% chance. What's the probability of drawing a heart? Well, there's 4 suits in a deck. There's a total of 13 hearts. Because 13 plus 13 plus 13 plus 13 equals 52. And that gives me 0.25 and 25%. What's the probability of drawing a face card where there's jack, queen, king, and there's 3 of each or 4 of each one of them? That comes out to be 12. So 12 over 52 is going to give me 0.23 or 23%. Like I said, if you don't understand where these numbers came from, just look at a picture of all the cards in a deck and count. It's not that bad. And once again, we're looking at this. What's the probability of drawing a face card that is red? Well, if you looked, we had a total of 12 face cards, and only 6 of them are red, so 652. 6 divided by 52 is about 11.5%. So each of those are answers. It's probably drawing a red card. 26, yeah, 26, because half of them are red. That's 0.5 or 50%. Let's look at drawing card number 2 through 5. So 2, 3, 4, 5. Each one of them has 4 cards. So that's 16 over 52. So 30.307, which is 30.7%. Actually, that would be 8. You rounded it. Alright, we're going to go ahead and skip this one. You don't even know that. And skip this one. You don't even know that. Alright, spinner. This is one you're going to be more familiar with. So that's first off, we got to count 1, 2, 3, 4, 5, 6. There's 6 spots. There's probability of spinner land on blue. There's blue. Or B, sorry. B here, B here. So 2 over 6. Which is the same as saying 1/3, which is 0.3 repeating, or 33%. What's the probability of not landing on C? So circle everything that's not C. So that means there's 5 numbers out of 6. 5 divided by 6 about 83, 0.83 or 83%. What's the probability of spinner landing on 1? So first we got to count that there's 8 numbers here, or 8 spots. What's the probability of landing on 1? There's a 1 here, 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 and here. That's half the board, so 4 over 8, which is 1/2, 0.5, or 50%. What's the probability of not landing on 1 or 2? Oops. So the only ones that are not 1 and 2 are these ones right here. So I got 2 over 8, which is 1 over 4, which is 0.25, and 25%. Alright, marbles. A bag contains 24 marbles. 6 red, 5 blue, 8 purple, and 5 yellow. What's the probability of selecting a blue? That's 5 over 24. 5 divided by 24, about 20, let's say 20.8%, or 208.20. What's the probability of selecting a purple? 8 over 24. That'd be 1/3 if you reduce it, which is 0.33 repeating, so 33%. There you go. A bag contains 24 marbles. Again, what's the probability of selecting a red or a blue? So that means we would take red, which is 6, plus blue, which is 5, and get 11 divided by 24. And get about, let's say 46, 0.46 or 46%. Alright, so don't worry about these problems. That's something we'll talk about a different one. Only 3 types of marbles. The probability of selecting a blue marble is 0.25, and the probability of picking a red is 0.45. What's the probability of picking a yellow? So blue plus red plus yellow equals 1. That's an important piece of information. Notice this right here. That'll help you with this problem. That means blue is 0.25, red is 0.45. We don't know why equals 1. So that means 0.25 plus 0.45 is 0.7. So that means this one has to be 0.3. These 3 have to add up to 1. That's why if you flip a coin, it's 50-50. 50 plus 50 is 100, which is 1. A lot of 100 bulbs during the manufacturing process is known to have 10 defective and 90 non-defective. If one bulb was selected here, what's the probability that is defective? Well, you do 10, which is the number defective, or the total number, which is 100, which comes out to be 0.1 or 10%. The company makes 1,000 cell phones a day. Only 8 are found to be defective. What's the probability, if you choose one at random, that it is defective? There's only 8 that come out to be defective, and a total of 1,000. So 8 divided by 1,000 is 0.008, or simply 0.8%. There's a difference. That's the decimal, that's the percent.